Okay. Now, what is hypothesis testing? Okay. Again, class, we are talking about statistical inference. So this one is under statistical inference. Okay. Statistical inference.
Madam, did you record?
Yeah, I have record. Hopefully I have record. Yeah, I record it. Thank you.
Thank you.
Okay. So the statistical inference that we are talking about is for single population. Okay, single population. In the last class, single population that we have discussed, we are discussing on how we can find point estimate. Okay, and for point estimate, we can refer to what we call population mean. Okay, and we also, if I'm not mistaken, also the population proportion. So what happened is that we know that when we estimate a point, we may mislead. Okay, our estimation could be not to the point that we are estimating. So that's why we have what we call interval. Then we go for interval estimate. And when we have interval estimate and we have seen how the interval estimate for mu and the interval estimate for proportion. Okay. So for the interval estimate for single population, okay, we have discussed this. Now, the third one is what we call as hypothesis testing. I put it as HT. Yeah? Okay, so here HT. The third one is hypothesis testing. How does this hypothesis testing differ to your interval estimate? Actually, hypothesis testing has relation to the interval estimate. Later on, we will see. After we covered the hypothesis testing, then only it will be suitable for me to go back to the point how the interval estimate will have to do with your hypothesis testing. Okay. So what is hypothesis testing? Okay. Compared to interval estimate, what you do is interval estimate, you just look for what will be the value of my mu and what will be the value of my p. Okay, by using my sample mean, I can estimate what would be my population mean. By using my sample proportion, I can see or I can find what will be my population proportion. Now, in hypothesis testing, okay, so when we discuss about hypothesis testing, so we may start with what is HT. Okay, so if I were to short form what is HT, okay, HT is a procedure. Okay, HT is a procedure to make division. Okay, to make division about what? About unknown population. Unknown population parameter. Okay, based on sample evidence. So now class, you can see if you think what will be the difference between interval estimate and HT. Now in HT, we just find the value. But in interval estimate, we only find the value, okay, of our mu and p, okay, based on x bar and p hat. Okay, just find the value. But now in HT, you are making a division. So when you make a division, it involves a procedure or a few steps for you to make that division. Okay. Now, what kind of sample evidence that we are talking about? So in your case, we are going to discuss the sample evidence for based on the sample evidence of X bar and P hat. The same as in interval estimate. So by using sample mean, we need to make a division. Okay, make division for our mean. Okay, so for P hat, we are going to make division for our population proportion. So that would be the first difference between interval estimate of mu and p and hypothesis testing of mu and p. Now, what is HT? Then we have answer. Now, why HT? Okay, why do we need to make division? Okay, so why HT is because, okay, first, HT is an essential, okay, essential procedure in statistics. In statistics. Now, second, why HT, okay, evaluates two mutually. Now, this is very important. Two mutually exclusive statements. Okay, statements about your population mean, that is your mu, and population proportion. That will be your means that by using X bar and P hat, we are going to make division for this mu and P. So how so? Okay. Now, how this can be transformed into what we call a statement? Okay, that we say as two statements that is mutually exclusive. Okay. So if I were to now class, the things that I share this will be a summary of a few pages of your introduction to hypothesis testing from page 84. Okay, so this is a kind of summary of page 84 until page 87, if I can see. Okay, it is a summary. Now, we know that we are going to make a procedure, and that procedure will involve few steps, and that step will involve what we call statement, two mutually exclusive statement. What kind of statement? If I were to put them in terms of what we call statistical statement, so you will have the one is null hypothesis, and the other one is the alternative hypothesis. Okay, so if you are referring to your, then it will go back to your mu, it will go back to your p. Okay, because this is the one that we are looking for. But in order to look for this, we use X bar and P hat. Okay, the same goes to here. Okay, now what kind of statement? If I can put that statement into a simpler form, so the first statement, example, it will be null mu equal to not. And the alternative would be mu equal not equal to mu not. Okay, and you can also have null mu equal to mu not, and mu1 h1 would be mu greater than mu not, or the third one h naught mu equal to mu not, h1 is mu less than mu not. Now look at the what we call the phrase here, the underlined phrase here. Okay, if you go back to the discussion of standard normal, if we look at this particular phrase, greater than, less than, we can imagine where is the area of the probability value that we are talking about. If this one, we can say this is as left tail test. Okay, left tail test. This one is right tail test. And this one is two tail test. Okay, so in short, we can have three types of investigation, which involve two tail tests. One tail test is either right tail test or left tail test. So this will be the statement that we are talking about. Okay, now what else should you know? Okay, now you should understand that what does this hypothesis, null and alternative means to you. Okay, so if you look at your textbook, your H now, okay, it is referring to a claim assumed to be true until evidence indicate otherwise. Okay, so that's what H now means in terms of the statement. What about the alternative statement? Okay, H1 means a claim to be supported okay, based on sample evidence. Is many of you trying beginning to lead my online class? Okay, I hope those are entering my class, not leaving my class. Now, imagine now that is more or less some of the introduction of the what we call hypothesis testing. Now, what is mu naught? Mu naught is the one that will be given, usually will be given to you. So this one, if I can put this in terms of, okay, this one is a value, okay, given in the equation. Okay, this value is what we call as hypothesized population mean. Hypothesized population mean. Why hypothesize? We are testing this value, whether our investigation that we are trying to make decision, the mu that we are looking for is actually is the same as the value that we testing. Okay, so that's why we call this as hypothesized population mean. Okay, now what else should you understand? Now from here, okay, from here, if I were to two tail test is because of this, right tail test because of this, left tail test is because of this. Okay, so this is how we decide which kind of test that we are using for our hypothesis testing. Now, okay, so there will be some other ways on how to put your statement into sentences. Okay, but as for now, I just remain for that particular what we call statement of hypothesis so that it will be easier. Later on, we will put it in terms of words. Now, when we do what we call the step of hypothesis testing, so if you put these are all concepts, okay? So how this will be helping in terms of the procedure next time. Okay, so YHT, and now I think it would be easier if I straightforward go to the procedure to perform hypothesis testing. Okay, so the third one would be, just now we have covered what is HT, then why is HT, then the third one, how we perform this. So the third one, how to perform HT. Okay, now if you look on page 86, turn to your page 86. Okay, so there will be three types of what we call hypothesis testing. The way we do the hypothesis testing, we can use what we call first traditional method. Okay, and the second one is p-value method. And the third one is what we call confidence interval method. Confidence interval method. Okay, now let's see how the first one is being done. Okay, how this is being done. The procedure wise are just the same. Okay, but the way we approach in terms of making the decision will be a bit different. Okay, so let's say we move to the first part, that will be traditional method of HT. Okay, if you look at the steps, so there will be 5 steps in finding the in performing the hypothesis testing. So steps, the first one is identify hypothesis statement, or identify the claim, okay, about the unknown parameter. If you are talking about mu, then you are writing mu. If you are talking about population proportion, then you are using p. Okay, and of course, you have to state the statement. State the H0 and H1. Okay. Second, what you need to do is find the critical value. So this critical value is the one that we have discussed in the previous chapter. So critical value. Okay. And this critical value is referring to your okay, later. So number 3, then compute test statistics. Okay, what are these? We will see afterwards, yeah. So test statistics, usually we are going to use the Z. Okay, that will be standard normal that we have covered in chapter 2. And the fourth step will be make decision. What decision is either reject now or fail to reject now. So this will be the 2 decisions that you are going to make. Reject now or fail to reject now. Okay, and finally make conclusion. Okay, make conclusion. Now I'm going to discuss about the critical value and everything when we solve the equations. Let's say we look at the first example of hypothesis testing. Okay, class, we have another 20 minutes. Okay, let's say we are talking about the example 3.6. Okay, example 3.6. Okay, a sample of 50 internet shoppers was asked how much they spend per year on the internet. From this sample, mean expenses per year on the internet is 1,300 Malaysian ringgit, and the sample standard deviation is 1,100 Malaysian ringgit. Is there sufficient evidence to reject the claim that the mean of yearly expenses is 1,500? Now, these are very critical in terms of what? Taking out all the information given in your question. Okay, so before we can move to our step, okay, as usual, I will always like to put down everything given in your question. So the first one, the sample size is 50. Okay, and the second one, from this sample, so from this particular sample, the mean expenses per year, so the mean of the sample is obtained by RM 1,300. Okay, and the sample standard deviation, so we know that sample standard deviation refers to S. So S is given by RM 1,100. Okay, is there sufficient evidence to reject the claim? Now see what is the claim, because claim appear in your first step. You need to know what will be your claim from the null and alternative hypothesis. Okay, so what is your claim? So look at your question, class. Is there sufficient evidence to reject the claim that the mean of yearly expenses is Rn 1,500? So in that case, class, your mu naught is given by Rn 1,500. So this is the hypothesized population mean that you need to test. Whether the population mean is actually equal to this value or not equal to this value. Now, since the word used is class, look at the word is RM 1,500, is means equal to. We know that just now when we are talking about our statement, okay, the statement can be in terms of this one, right? It will be your now statement. It will be your now statement. Now, since your question is about is, so the pair that need to be used for your investigation will be this one. Because if you are being asked whether it is equal to that value or not, then you are going to test this one. If you are being asked, for example, let's say the question I author to this one, is there sufficient evidence to reject the claim that the mean of yearly expenses is greater than 1,500, then your statement of H0 and H1 will be correspond. So greater than RM 1,500. So this will be the statement. If the question asks, is there sufficient evidence to reject the claim that the mean of yearly expenses is smaller, so smaller than RM 1,500, then this will be the pair of H0 and H1 that will be used in your statement. Okay, class? So I hope by now you have understood what is hypothesized population mean, which is given in your question, and you need to look and you need to test whether, so the first step here, step 1, okay, from here you will have your null is mu equal to 1,500. Let's say I remove the Rn. Then the alternative will be mu not equal to 1,500. Now, where is the claim? Because I said just now, first step, you need to find what will be the claim and state down what will be the null and alternative. So in this case, I have the null and I have the alternative statement, but where is the claim? So look back to your question. The question asks whether you have sufficient evidence to reject the claim that the mean of yearly expenses is RM 1,500. So this becomes your claim. Okay, so you are going to test whether this claim will be rejected or fail to be rejected. So that will be step 1. Step 2. Okay, step 2 require you to find the critical value. Okay, so in this case, okay, critical value. Now, in this case, you need to look at your sigma, known or unknown. For what we call mean, it will be 2 conditions involved. Either sigma is known or unknown. If it is known, definitely you are going to use your Z alpha over 2. Because this is a two-tail test. Okay, this is a two-tail test. Okay, so it will be Z alpha 2. If it is unknown, so if you have your what we call okay condition, so known or unknown. So if you have unknown, so this will be, so I rewrite again. So this would be your Z alpha equal to your mean of your x bar minus your mu naught divided by known, it will be sigma over square root of n. If it is unknown, so you will have two situations. It's either sigma unknown and greater than or equal to 30. So your Z would be x bar minus mu naught divided by sigma over, S over square root of n. If less than 30, okay, so if it is less than 30, you will have to use T as your critical value. Okay, so T x bar minus mu naught divided by S over square root of n. Okay, so in this case, class, since the condition now is given, sigma is unknown. So in this case, unknown sigma. And we know that our n is greater than 30. So we are going to use this formula. So your Z would be x bar minus mu naught divided by S over square root of n. So this would be x bar would be, your mean is 1,300. Okay, so 1,300 minus 1,500, the hypothesized value, divided by 1,100 divided by square root of 50. So you will get, in this case, you will get negative 1.286. Okay, class, we are still referring to the same standard normal distribution that we discussed earlier on. Okay, for the PI as well as the what we call the probability distribution. Now, we have found our critical value. Now, what is this critical value mean? If you are referring to your what we call distribution of your standard normal, where the mean is equal to 0, and the area that you are talking about is this particular area, which is negative 1.286, is at this particular shaded area. Now, this is your critical value. Now, step 3. I think I will just stop until step 3 because I have class at 3:30. Okay. So at third step, you need to find the test statistic. Okay, so test statistic plus critical value. This is the test statistic of class. Yeah? It's okay lah, class. I miss out. This one is actually what we call test statistic. Okay. Now, if I change the test statistic, this become is actually can do either you find the critical value first or test statistic first. Okay. Let's say the third step will be the critical value. Critical value will always be using the Z alpha over 2 or the alpha only. Critical value. Okay. Now, since alpha that we are talking about is given in your equation is alpha 0.05. Okay. And we know that this is a two-tailed test. Okay. So a two-tailed test means that we need to find what will be the Z alpha over 2 given by Z 0.025, and we know that it is given by plus minus 1.96. Now, if I were to what we call make the division, step 4, sorry, I've just finished after step 4. Make division. Okay, we know that the okay, how to make division. We are going to use answer in 2 and 3. Okay, I have my critical value. Okay, my critical value is for Z alpha over 2 is plus minus 1.96. Let's say negative 1.96 is over here. This is the area where the alpha over 2 belongs to. And this is the other area for alpha over 2 given by 1.96. Now, by using your critical, what we call test statistic that you obtain in your second step, that will be given by this Z, okay, equal to negative 1.26. So look for the location of negative 1.286. So if you have Z equal to 0 here, then 1.26 will be somewhere over here. Okay, 1.286 negative. Now, class, how do I make division? Okay, class, for this particular area is what we call non-rejection region. Here, this shaded in red is what we call rejection region. The same goes to this part. So this is what we call the rejection region. Now, since our test statistic negative 1.286 falls between the non-rejection region, what will be your division? So in this case, therefore, we fail to reject null hypothesis. Class, whenever you make division, always refer to your null hypothesis, even though your claim could be in the null or could be in the alternative. So I guess we just stop here and we are going to continue somewhere next week. Okay. For those who have any question regarding your tutorial, so I think you can still what we call contact me if you have any question.